Okay, YouTube, in this video we're going to be exploring how to construct a compound box plot or a compound box and whisker plot. So essentially, sometimes we want to analyze two or more different sets of data and compare them. And it's really easy to do when you have a graph, of course, and one very nifty graph to use is a box plot. So in such instances, we'll be able to construct two or more sets of data on the same axes using just box plots that we stack atop one another, okay? So to compare the averages, we can just use a location of a median as opposed to the actual mean. And to compare the variability or how it's spread apart, we'll just look at their interquartile ranges. So when we're done constructing these two box plots for these two sets of data that we look at here in a second, we'll compare them just by comparing where their middles are and how their spreads compare as well. So let's consider this. It says the following table shows the scores recorded on a ProbStats quiz that was taken by two separate classes. So we have Class A and their performance on the quiz, and then Class B and the performance on their quiz. And let's say it's a 15-point quiz. Okay, we want to include that there, same. But we want to come up with a box plot that is a compound box plot. So instead of making two separate graphs, it'll be a lot easier to compare if we put them on the same graph. And as a matter of fact, before we can do this, what we're going to have to do is come up with a 5-number summary for each of these data sets. So the 5-number summary, recall, is the minimum, the end of the first quartile, the end of the second quartile, or the median, the end of the third quartile, and then the end of the fourth quartile, which is always the maximum here. So we say we want to come up with these data for each data set. And I'm going to list this one off on the side here. M, Q1, Q2, Q3, and then the max. Okay. That way we leave ourselves some room at the bottom there. So as far as the min and the max go, those are two very easy things to find. I've already aligned these data so that they're in order. But we said the minimum score out of 15 here was a 5 in this class, and the maximum score was a 15 itself. And we say also over here, we say the minimum score, well, it was a 2. That person must not have studied. But the maximum score was a 15. Okay. So as far as finding these other measurements here, we start by finding Q2 or the median each time. So counting in from the outside here, we say, okay, so 1, 2, 3, 4, 5. I'll count in 5. 1, 2, 3, 4, 5. And we say, okay, count in here, count in here, count in here, count in here. And it looks like we land right between a 12 and a 13. So the median of 12 and a 13 would be their average. And we end up with 12.5. Okay, so 12.5 is the value of our median datum, even though it wasn't a part of the original data set. That does represent the median. And then now we just need to find the median of the first half of data, which means we'll start inside this 12.5 and start counting in. So 12 counting in, if I count in 1, 2, 3 this way, and I count in 1, 2, 3 this way, you'll notice that it splits amongst these two 12s. So we say Q1 is this 12 right here. So we say Q1 is a value of 12 points. And then counting in the other way, starting at this 13, we say 1, 2, 3. We'll count backwards 1, 2, 3. Looks like it gets split amongst the 13 and the 14 here. So splitting those in half, we say their midpoint would be this Q3 value, or 13.5 points on this quiz. Okay, so we have our 5-number summary for the first class. Let's take a look at the second class. So we say, all right, counting in. Be careful here because I've given a different number of data in each set. So we say 1, 2, 3, 4, 5. I'll just count in 6 this way. So 1, 2, 3, 4, 5, 6. So 1 here, 1 here, 1 here, 1 here, and then here we split it amongst these 12s. So we say our Q2 has a value of 12 points on the quiz. We label this, we say Q2. We'll count inside, starting at this 12 right here. Go 1, 2, 3, 4, 1, 2, 3, 4. I notice that I just land on this 9 right here. So we say Q1 is 9. And then we say, okay, coming over to the other side, we got 1, 2, 3, 4. 1, 2, 3, 4, and we land on this 13. So 13 is the end of our third quartile. So now that we have the 5-number summary for both of these, we say that the minimum here is 5, max is 15. Here the minimum is 2, max is 15. To choose an appropriate scale, I think that we should probably, to fit this on the number line, we say let's start at 0, and then we'll say go up to 15. We didn't even go by 1. So we say 1, 2, 3, 4, and then we'll just label 5. We'll make it bigger than the rest. 6, 7, 8, 9, we'll put 9 here. 10, okay, 11, 12, 13, 14, 15. So when constructing a compound box and whisker plot, we're going to put these data above the number line. It's just that we're going to stack them. So for class 1, class A here, why don't we do this? And I'll change out my color scheme. We will do class A in this lighter teal, and we will do class B in a green. So class B will be this green color and a lighter teal for class A. So class A, we would put a dot above the 5 here, That was our minimum datum. We say 12, 12 is going to be here. And then we have 12 and a half, so splitting there. And then 13 and a half would be here. And then 15. So our whiskers, of course, go from the minimum to Q1 and then Q3 out to the maximum. And then the box would just go around these middle three data here, with our median being right there in that line right there, the middle dot. So now, doing class B in green, we say that the minimum datum was 2. So this is actually going to be right above 2. We'll just stack this on top of the other box. So 2. And we say 9. 9 is the Q1 value. So we say, here's my 9. And then we say 12 is my median. 13 is our end of our third quartile of data. And then 15 was the maximum here. And what we seek to do is compare these two data sets. But when we say compare them, it's not okay to just say, well, the other one spread farther than the other one. No, we want to use words like median, IQR, okay, skewness. So what I want to do is compare the performance of each of these classes on this quiz, and I want to include information about the median scores, ranges, interquartile ranges, and skewness. So what conclusions can we draw? Well, if I said, well, which class performed better, it seems that we could say that both classes got the same maximum score. So that's one observation we can make about this. Well, you know, we had somebody in each class, at least one person, get the maximum score out of 15 on this quiz. But I could say this, for class B, well, you had at least one person who really didn't study because the minimum score was way down here. And even here, you know, this person probably didn't study a 5 out of 15. But we could say that both of these box plots, I noticed that the lines are way long on each side on the left. So we say both are left skewed. Okay, that is, we had somebody in there that threw the data off on the left. Okay, we say both have a max of 15 points achieved. What else might we want to mention about this? Well, the median score. Up here, we see that the median score is 12.5, whereas right here, we say that the median score on Class B was a 12. So we would say that Class A, we say class. We'll just make that a capital L. Actually, I can't do that. We say Class A has a higher median score. Okay, and we could say is also more condensed. It was more packed together. So what can we do to support this? We could say that Class A had a range from 5 up to 15. So the range here is 10. And we could say that its interquartile range from 12 to 13.5. That is a distance of 1.5 for the IQR here. Okay. Whereas when we look at Class B, we say that its IQR went from 9 all the way up to 13. So 9 to 13 is 4 is its IQR. And then its entire range was a huge range. It was spread very, very far. So we say the range here would be 15 minus 2, which is 13 units. So we say that this is more condensed, and we can just back this up by talking about the IQR as well as the range, the whole range. And then I suppose last but not least, we would say that the middle 50% of data on this here, which corresponds to the IQR, clearly we can see that its box is a lot more packed together than this one right here. Okay, but for the most part, I would say that the good news is this. For this data set here, we'd say that 50% of the people got above a 12.5 on this quiz. And for the Class B, as much as we had some people on the lower end, we had 50% of our people got a 12 or higher on this quiz, which is, you hope, encouraging. Okay, so the last thing I want to mention here is a vocabulary kind of, not a phrase, but kind of something we learn here, vocabulary term, okay? But it is a resistance statistic. And so when we talk about box plots, you notice that I keep talking about the median and not the average, okay? And I keep talking about the interquartile range as opposed to the actual full-on range, okay? And the reason why is because we consider the IQR, okay, IQR, and the median to be resistant. We call these resistant statistics. And the reason why they are resistant statistics, if you haven't gotten these figured out yet, why we call them resistant statistics, is because if we were to throw in very large, very small data, that is like outliers, okay, you would see that an average, you know, throwing in a big or a small value, it would throw the average off, okay? Or if you were to look at the whole range here, if you were to throw in a really small value, like we have this 2 down here, it really throws off the range of the entire data set. So we say that what's better than just the range, we say that the IQR is better than this. We call it resistant because even if you were to throw in a really big value, like Class B, let's say that the quiz was 15 points and somebody was so awesome that they got 100 on it. I mean, that's way out here. This whisker would go off my screen. You would see that it really wouldn't change the IQR very much. So resistant statistics are statistics such as the median and the IQR, but simply because they are less affected by outliers than are non-resistant statistics such as the mean or the overall range. Cheers.